Hello students, welcome to my channel Physics with Sambhumitrasir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please do not forget to press the like button and share this video. So this actually gives me more motivation so I can bring more number of videos for you. So today's topic is critical angle and total internal reflection. Let's start. Okay. So first topic is, what do you mean by critical angle? Remember, this concept is so important that we can apply this concept in many cases of light, correct? So let me discuss it in a detail first. First of all, think about this is surface of separation of two media. Okay. For example, let me draw a medium first. That will be much more better. Okay. So let's draw a medium. Let me draw a color for medium. So it looks more bright for you. And let's give you some border on it. Okay. Now watch this very carefully. Say for example, there is an object placed in this medium, correct? Let me mark this object by a different color. Let me use red color for that. Okay. Now watch. These are medium which is denser with respect to the outer medium, correct? For example, let me write this medium as medium 1. And this is medium. The refractive index of medium 2 is more than mu1. Correct? That means refractive index of medium 2 is more than 1. Let me mark it mu2 and let me mark it mu1. Now what will happen? Say for example, if a ray of light goes straight from here, so actually when a light ray goes out, correct? So it moves like this, correct? It means actually moving from denser to rarer medium. So and it is falling along the normal, so no deviation will take place. You will know that, correct? Now what will happen if a ray of light bends? Okay. So I am taking 3 different rays first. Okay, I'm taking 3 different rays first. Now watch this very, very carefully. What is happening? What is happening? Let's draw a normal first. Let's draw a normal first. Drawing normal for each of these rays. If you watch this figure very carefully, you will find that slowly this angle of incidence where light is moving from denser to rarer medium slowly increases. Correct now? So assuming this is angle I. Okay. So what will happen? It's a general thing. When light ray will move out of this medium, it will bend where it will bend away from the normal, since it is moving from denser to rarer medium. Correct? Look. Now, technically, if you watch this thing carefully, as it goes out, okay, it is moving away from the normal. That means if I mark this by red mark, it is R. And watch it, R is more than I. So it is quite clear, if I go on increasing the value of I, the value of angle R also increases. And slowly, as the value of angle R will increase, this ray will move more towards the separation of the two media. Correct? Is it clear? In this way, when this angle of incidence, that is I, is equal to a special angle theta c, when I is equal to theta c, these rays of light will go like this. Okay? As a result of which, what will happen? This angle would be 90 degree. Clear? This angle would be 90 degree. Is it clear? And this particular angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degree, is called critical angle for that pair of medium. Okay, so remember, when light ray moves from denser to rarer medium, it always moves away from the normal. Correct? That means angle R increases. So if you go on increasing the value of I, the value of R will be more. And as the value of R will be more, what will happen? This light ray will move more towards this surface. And ultimately, a situation will arise for a particular angle of incidence. This light ray, okay, will move along this path. This is called grazing, correct? Grazing the surface. This particular angle of incidence in the denser medium, for which angle of refraction in the angle of refraction in the rarer medium is 90 degree, is called critical angle for that pair of medium. So, what is the definition of critical angle? The angle of incidence in the denser medium, be careful, in the denser medium for which angle of refraction in the rarer medium is 90 degree is called the critical angle for that pair of media. Okay, that means pair of media means what? If I interchange this medium, the value will be different. Correct? That is the meaning of the pair of media. Now let us try to establish a relation between critical angle and refractive index. Okay. Now look, in this case, light ray I is equal to theta c, and R is equal to 90 degree. And if I apply Snell's law, mu2 sine of I is equal to mu1 sine of R. Mu2 is what? This. Sin I means sine of theta c. Mu1 is what? This. Sin R is what? Sin 90. Clear? So what we can write, mu2 sine of theta c is equal to mu1 sine 91. Therefore, we can write sine theta c is equal to mu1 by mu2. Okay, now watch it carefully. What we know, what is the meaning of 1 mu2? What is the meaning of 1 mu2? 1 mu2 is equal to mu2 by mu1. Okay. So, what is the meaning of 1 by 1 mu2? That is equal to mu1 by mu2. Is it clear? Now, if I replace this value of mu1 by mu2 by this value in this equation, then it will come like this: 1 by 1 mu2. So this is the relation between critical angle and refractive index. So what we can write it? Sine theta c is equal to 1 by 1 mu2, or theta c can be written like this: sine of inverse, it is not to the power minus 1, 1 by 1 mu2. Okay, inverse means angle. Okay, so this is the relation between critical angle as well as the refractive indices, correct? So it's a very good important thing, correct? So let me draw few sums related to this. Let me do few sums related to this. Then I will come to the topic of total internal reflection. So let me erase this, okay? For an example, let us assume the denser medium in this case is, say for example, glass. Okay. Assuming the medium 2, assuming medium 2 is glass and medium 1 is air, then what will happen? Remember, absolute refractive index of glass is 3 by 2. Okay, absolute refractive index of glass is 3 by 2. So what will I do? I will use this formula, correct? So what is the value of 1 mu2? What is the value of 1 mu2? We know that mu2 by mu1. Okay, so mu2 is 3 by 2 and mu1 is air, its refractive index is 1, so it is 3 by 2. Clear? Now, say for example, if I put this value here, sine theta c, 1 by 1 mu2. 1 mu2 is 3 by 2, so 1 by 1 mu2 would be 2 by 3. Remember, the value of sine 42 degree is approximately 2 by 3. Correct? So theta c is equal to 42 degree. Actually, it is slightly more than this, but we approximate is 42 degree. So remember, for glass air combination critical angle is 42 degree. Is it clear? Now, this case 1. Assuming another case, okay? What is that? Suppose medium 2 is water and medium 1 is air, and refractive index of water is 4/3. Correct? So apply the same rule again. So what will be the value of theta c? Look at this. Apply the same rule again. Sin theta c is equal to mu2 by mu1. Okay. So mu2 by mu1 means in this case it is 4/3. Clear? 4/3, and that is equal to 1 by 1 mu2, that means 3/4. And the value of 3/4, sin 3/4 is actually equal to sine 49 degree. So sine theta c is equal to approximately sine 49 degree. So for glass air it is 42 degree, and for water air the critical angle is 49 degree. Correct? So if suppose air is not given, any other medium is given, no problem. You can apply this formula and you will get the result. Is it clear? Let me show you one. Okay. Suppose it is given the speed of light in medium 2 is v2, and speed of light in medium 1 is v1, and it is greater than that, v1 is greater than v2. That means obviously medium 1 is denser than medium 2. Correct? So question is, find the sine of critical angle for the pair of media. In terms of V1 and okay. So as usual, what will I do? We'll do it like this. What is the meaning of 1 mu2? Okay, it is the ratio of the speed of light in medium 1 to speed of light in medium 2. Or what we know, 1 mu2 is equal to mu2 by mu1. Mu2 is called absolute refractive index. We can replace this by C by V2 and this by C by V1. Therefore, it is equal to V1 by V2. Correct? Now, we need to find out the value for 1 by 1 mu2, which will be equal to V2 by 1. Now, what we know, sine theta c equal to 1 by 1 mu. Therefore, sine of theta c is equal to 1 by 1 mu2 is V2 by V1. This is the answer, because the question is find the sine of critical angle for the pair of media in terms of V2 and V1. Correct? This is the idea of the critical angle. Now the question is, if any ray of light falls on the separation greater than the critical angle for the pair of media, so what will happen? Correct? Look, then what will happen? Look, if a ray of light is now falling on this surface of separation at an angle which is greater than the critical angle for that pair of media, means I greater than theta c. Be careful. Now what will happen? No light will be reflected. No light will be refracted the entire light ray will be reflected, correct? Entire light ray will be reflected. Clear? That means no refraction, same portion of the light ray gets reflected back in the same medium, and this phenomenon is called total internal reflection. Total internal reflection, or in short it is also called TIR. Okay, so what is the definition of TIR? Now it is that when light moves from denser to rarer media, correct, falls at an angle of incidence greater than the critical angle for that pair of media. Always remember, for that pair of media. Okay, then no light will be refracted and 100% of the light will get reflected back in this same media. Okay, clear? And the phenomenon is called total internal reflection. Is it clear? Is it clear? Now the question is the factors on which total internal reflection depends. Means what is the condition of total internal reflection, correct? So condition of TIR. Condition of TIR. Okay. Number one condition, the light must move from denser to rarer media. Okay. Number two, the angle of incidence in the denser medium must be more than the critical angle for that pair of media. Okay. What is the advantage of this critical angle? There is a technique of sending signal from one point to another through a fiber-like channel called optical fiber. Okay. Here, light moves from one point to another by the method of total internal reflection. Okay. So this is a very, very important concept. Optical fiber totally works on the principle of total internal reflection. Clear? And the shining on diamond, etc., are very useful example of TIR. Now, I am going to show you something. Before going to show you some application of TIR and critical angle, let me tell you something about the factors on which critical angle depends. Correct? So, factors on which critical angle for a pair of medium depends. Okay. Number one, it depends upon the color of light, which is also color means it depends upon the wavelength of light. Okay. Remember, different colors have different wavelengths. So, for the same pair of media, for different colors of light, critical angle will be different. Just giving an example. The speed of red light is more than the violet light. Violet light in glass. Okay. That means what? We can write V of red light is more than V of violet light. Let me write it like this. Now, what we know, sine of theta c is equal to 1 by mu. Okay, where mu is the absolute refractive index. Clear? Now, let me do it for different colors of light. Now, say for example, theta r is the critical angle of red light for glass, air, and theta v is the critical angle of violet light for glass, air. Okay. Now what will I do? Sine theta is equal to 1 by mu. Okay. Now watch this very carefully. What we know? Formula for mu equal to C by V. So mu for red light is equal to C by VR, and mu for violet light would be C by V violet. Now, if I find the ratio of it, mu R by mu V, which would be equal to C by VR into BV by CC get cancelled. Therefore, velocity of violet by velocity of red. Now, which is larger? Red light, velocity of red light is more than velocity of violet light. So this ratio is obviously less than 1. That means mu R is this. What does that mean? That means the refractive index of violet color of light is more than red color of light. Now watch it, sine theta is equal to 1 by mu. That means critical angle is inversely proportional to this, correct? So let me show you the calculation. Okay. Now, let's do it in this way. Sine of theta r is equal to 1 by mu of r. Okay, let's make it equation 1. Sine of theta v is equal to 1 by mu v. This is equation 2. Now, if I divide these two, sine of theta r by sine of theta v, if I divide these two, we'll get what? Mu v by mu r. Okay. Now, which is larger? Mu v is larger than mu r. That means this ratio is greater than 1. That means sine of theta is greater than sine of theta v. And we know if angle increases, sine theta increases. That means theta for red color is more than theta for violet color. That means for the same pair of media, critical angle is different for different colors of light. Is this clear or not? Clear? Okay. So now, this is one of the factors on which critical angle depends. Number 2 factor is this, that is effect of temperature. Okay. What is the effect of temperature? In general, what happened? Refractive index decreases with increase in temperature. Ri decreases with increase in temperature. Okay. Ri decreases with increase in temperature. Clear? So what will happen? Since Ri refractive index decreases with increasing temperature, so as temperature increases, look, refractive index decreases. As temperature increases, refractive index decreases, hence critical angle. What will happen? If refractive index decreases, critical angle increases. Is it clear? Is it clear? So this is why total internal reflection takes place in mirage. Correct? In mirage formation. What happened? As we move higher and higher, correct? As we move higher and higher, refractive index decreases. And light moves from lower, we'll say for example, there is a pond. Okay, and you are here. Clear in desert. What happened? Since the layers of air, okay, in different layers, as we move up, critical angle refractive index slowly decreases. So what is happening? Light is moving from denser to rarer medium, and when it suffers total internal reflection, it goes back like this. Clear? And for the observer, it seems like there is a pond or something, a source like this, and that is the confusion. So this is the concept of critical angle and total internal reflection. But some of the important things takes place with this critical angle and total internal reflection in case of prism. So now I'm going to discuss with you the application of critical angle, in prism. Okay. So before proceed further, let me show you one example related to this. For example, a picture is given like this to you. Okay, and is given there are 3 days. There are 3 days going like this. Okay, this is ray 1, this is ray 2, and this is ray 3. We have to complete the ray diagram. So what is the procedure? I told you this earlier also. In order to complete the ray diagram, first draw the normal in each case. Okay. Now watch it. It is quite clear from the figure that this ray is grazing the surface, so this critical angle. And it is less than critical angle, and it is more than critical angle. As a result of which, what will happen? This ray of light will be refracted. Okay, this ray of light will be refracted in the rare medium. This ray of light will be refracted in the rare medium, and this grazes the surface, so it is critical angle. And since it is more than critical angle, in this case, what will happen? Total internal reflection will take place. So this is the technique of completing the diagram. Correct? So this you will get more this type of diagram, and you have to proceed it like this. Correct? Now the topic is how to apply the concept of critical angle in drawing diagram related with prism. Clear? So there is a type of prism called total reflecting prism, whose configuration is 90 degree, 45 degree, 45 degree. It is also called right angle, isosceles prism. Okay, 90 degree, 45 degree, 45 degree. These also called right angle isosceles prism, and the prism looks like this. This angle is 90 degree. This angle is 45 degree, and this angle is 45 degree. Correct? Now I'm going to show you how, with the help of total reflecting prism, one can produce a deviation of light ray by 90 degree, by 180 degree, or how to form and reverse image, form a reverse image of the object. How to form a reverse image of the object. Okay, please continue to watch my next video where I will complete all this concept. Clear? Thank you.